All right, get ready to dive deep because today we're tackling something that'll really stretch those philosophical muscles, backward causation.
Ooh, that's a good one.
It is, right?
Yeah.
Can you even imagine an effect happening before its cause?
I mean, it's definitely one of those things that makes you kind of cock your head to the side.
Like knowing the outcome of a coin toss before it even happens.
Yeah, exactly.
Okay.
Just kind of feels wrong.
It does, and that's what makes it so fascinating to think about. And for this deep dive, we're relying on the Stanford Encyclopedia of Philosophy's entry on backward causation. So we're going full-on philosopher mode here.
Buckle up.
Yes, buckle up, exploring the intricate arguments and counter-arguments surrounding this mind-bending concept.
So when we talk about backward causation, it's not something that's been like a, central debate in philosophy for centuries.
Right, it's not like Plato and Aristotle were going back and forth about this.
Exactly. It's a relatively new debate. It gained a lot of traction in the mid-1950s.
So who were some of the key thinkers who brought this idea into the philosophical spotlight?
Well, there are a few, but the two that really stick out are Michael Dummett and Anthony Flew.
Okay.
And they really started digging into the implications of backward causation. And, they saw it as this challenge to traditional linear views of time and causality.
That makes me wonder, how did earlier philosophical giants like Hume and Kant view this concept? Because they were so invested in understanding causation.
Yeah, absolutely. Hume, for instance, he defined a cause as the event that precedes its effect.
Okay.
So already right there,
Yeah.
backward causation.
It breaks it.
Seems almost impossible. It just doesn't compute. And Kant, too, held a pretty similar view that, the cause preceding the effect was just like a fundamental truth.
So backward causation is already shaking things up just by questioning these long-held assumptions about temporal order. But how does this challenge our understanding of time itself?
Well, to really grasp that, we need to think about the three main views of time that philosophers often discuss: presentism, possibilism, and eternalism.
Okay, let's break those down just so we're all on the same page.
All right, so presentism, that's the view that only the present moment truly exists, the past is gone, and the future hasn't happened yet. Then we've got possibilism, sometimes called the growing block universe. This sees both the past and the present as real, but the future is just this collection of possibilities waiting to happen.
Okay.
And finally, we have eternalism, also known as the block universe. And in this view, the past, present, and future all exist equally, like points on a timeline.
Okay. My brain is already doing some philosophical gymnastics here.
Yeah, it's a workout.
It really is. It seems like backward causation really needs that eternalist view of time to even be possible, right? Because for a future event to influence the past, the future needs to exist in some way.
That's a key point. You're absolutely right. Backward causation really implies that the future isn't just a bunch of potential outcomes, but in some sense, it's already there. It exists as concretely as the past and the present.
And this raises another question. Does that mean the future can actually change the past?
That's a big one, and it's a question that leads to a lot of those head-scratching paradoxes that we'll get into later. But most folks who support the idea of backward causation, they'd say that the future doesn't so much change the past as it influences it. It's more like this fixed relationship between events across time rather than one event actively altering another.
Okay, so it's like the future's already written, so to speak,
Yeah.
but our actions in the present are still part of that script.
Exactly.
Okay, but if we're letting go of temporal order as our defining feature for causation, how do we even determine which event is the cause and which is the effect in backward causation?
That is the million-dollar question. It's a tough one.
Right. It's like we need a new rule book.
Absolutely. We need a way to define causation that goes beyond that simple temporal sequence. And as you might have guessed, it's not an easy task.
And I feel like this difficulty in defining causation without relying on time really ties back into some of the challenges that philosophers like Hume encountered, right?
Oh, you're spot on. Hume's definition, which was based on temporal precedence. It just doesn't work when we're talking about backward causation.
Yeah.
It just breaks down. So because of this, philosophers have had to explore other ways of defining cause and effect.
So what are some of the alternative approaches that have been proposed?
Well, one of the most prominent ones uses counterfactuals, those what-if statements.
Right. What if I hadn't eaten that whole pizza last night?
Exactly. I wouldn't feel so terrible today. So counterfactuals let us imagine different outcomes.
So how do they help us understand backward causation?
Well, philosopher David Lewis, he used counterfactuals to define causation.
Mm-hmm.
He argued that an event is causally dependent on another if it wouldn't have happened without that other event. So with backward causation, you could say If this future event hadn't happened, this past event wouldn't have occurred.
Oh, so we're establishing this link where the future event is essential for the past event to occur, even though it happens later.
Yeah. Exactly. But even counterfactuals, as useful as they are, they run into a little snag. We encounter what's known as the problem of effects.
Okay, I have a feeling this is where things get even trickier. What's the problem of effects, and how does it mess with our understanding of backward causation?
So the problem of effects pops up when we try to define causation only through counterfactuals. It basically creates a scenario where both the cause and the effect seem to depend on each other.
Okay.
So if we're saying that the cause caused the effect and the effect caused the cause, aren't we just going in circles?
It's a bit like a chicken and egg paradox, but with time travel thrown in.
Exactly.
So if counterfactuals aren't a perfect solution, what are some other ways philosophers have tried to define causation without relying on time?
There are a few other paths they've explored. Some philosophers focus on probabilities, suggesting that a cause just makes its effect more likely to occur regardless of when it happens. Others focus on the idea of manipulation or intervention. Like, if you can manipulate one event to make another one happen or prevent it from happening, you've got a causal link, even if the effect happens before the cause.
Okay, that makes sense. We're basically trying to get to the core of what causation is beyond our usual time-based framework.
Precisely.
And this reminds me of something we were talking about before we started recording. Some folks even suggest that causation is tied to the transmission of information,
Right.
or the conservation of physical quantities, or even our evolved ability to interact with the environment.
It's like maybe our understanding of causation comes from our need to manipulate the world around us to survive, you know?
Right.
If our ancestors couldn't figure out cause and effect, we probably wouldn't be here.
That's a fascinating thought. It's like our brains are hardwired to look for causal relationships because they were essential for survival. But speaking of challenges to backward causation, we can't forget about Max Black and his famous bilking argument. Now, that one throws a real wrench into the works, doesn't it?
It definitely does. It's a major hurdle for anyone who believes in backward causation. Black used the example of a magician like Houdini predicting the outcome of a coin toss.
Okay, I'm picturing Houdini on stage about to do his thing.
So even if Houdini gets it right, Black argued that you could always intervene after the prediction is made and change how the coin lands.
So Black is basically saying that because we can step in and change the outcome, the prediction couldn't have been the real cause. But how do people who believe in backward causation respond to that?
Well, they have a couple of key counterarguments. One is that even with regular forward causation, we can often intervene to stop an effect from happening.
Right, like taking medicine to avoid getting a cold even though you've already been exposed to the virus.
Exactly. And that doesn't mean the cold wouldn't have been caused by the virus if you hadn't taken the medicine. Similarly, just because we might be able to prevent some backward causation scenarios, it doesn't automatically mean that a future event didn't genuinely influence the effect.
So the possibility of intervention doesn't rule out backward causation. It's more nuanced than that.
Much more nuanced.
Are there any other ways to challenge Black's argument?
Definitely. Some argue that Black's argument focuses too much on physical actions and ignores the possibility of backward causation happening with information or meaning. To illustrate this, let's go back to Houdini and his coin toss predictions. Imagine 3 different scenarios.
Okay, I'm ready. Lay it on me.
All right, so in the first scenario, Houdini makes a prediction, the coin is flipped, and his prediction matches the outcome pretty closely.
Okay.
So far, so good. Right. On the surface, it seems like there could be some backward causation going on.
Yeah, it does seem like the future event, the coin toss outcome, is somehow influencing his prediction in the past.
Yeah.
What about the second scenario?
Okay, so in this one, someone messes with the coin toss to make sure it goes against Houdini's prediction.
So they're deliberately trying to make him wrong.
Exactly.
But wouldn't that disprove backward causation?
Not necessarily. You could argue that the act of someone rigging the coin toss is what made Houdini make a prediction in the first place, regardless of whether it was right or wrong.
I see. So the physical action itself, rigging the coin, is what's influenced by backward causation, even if the specific outcome is being manipulated.
That's the idea.
That is a really interesting distinction. What's the third scenario?
Okay, so in this one, Houdini makes his prediction, but sometimes someone stops the coin toss from happening altogether.
They just say, nope, no coin toss today.
Right. And what we might see is that Houdini only makes predictions when he somehow knows that the coin toss is actually going to take place.
So his prediction isn't just random. It's tied to whether the future event of the coin toss will actually occur.
Precisely. Even his decision not to make a prediction could be linked to the future event of the coin toss being prevented. It's like he's getting information from the future, even if he's not consciously aware of it.
These scenarios really make me rethink Black's argument. It's not as simple as it seems. It's not just about whether we can intervene. It's about understanding what is being influenced and how. This whole discussion about backward causation is really making me question our everyday assumptions about time and cause and effect. But before we get too comfy with the idea that the future might be messing with the past, what about the big elephant in the room, free will?
Yeah, if the future can influence the past, does that mean our choices don't really matter? It's like, are we really in control or are we just puppets?
Right, it's a huge question.
Right.
It's like the ultimate philosophical dilemma. If the future is already set, are we just going through the motions?
This is where it's super important to understand the difference between a determined future and a determinate future.
Determined versus determinate. Okay, there's a subtle difference there, but I think I'm getting it.
A determined future means that what happens in the present directly causes and guarantees specific outcomes in the future. It's like a chain reaction. You know, each event leads inevitably to the next.
Okay, like dominoes falling one after the other.
Exactly. But a determinate future just means that the future is fixed, but not necessarily because of things happening right now in the present. It's more like knowing where you're going on a trip, but not knowing the exact route you'll take to get there.
So with backward causation, we're saying that the future is determinate, not necessarily determined.
Right. It's like the destination is set, but maybe there are different paths to get there.
Okay, that's an important distinction.
Right.
But how does that fit with the idea of free will? It still feels like if the future's already there, our choices are meaningless.
This is where that eternalist view of time we talked about earlier really comes in. Even if the future is fixed, it doesn't automatically rule out free will.
Okay, help me wrap my head around that.
Yeah.
How can we have free will if the future's already laid out?
All right, let's try a thought experiment. Imagine you're deciding whether or not to visit your parents tomorrow.
Okay, I'm picturing it.
Now, from an eternalist perspective, that future event, you visiting your parents, it already exists in the block universe. It's a fixed point in space-time.
Okay.
But that doesn't mean your decision in the present isn't what makes that future event happen.
So in a way, my decision right now is what creates that fixed point in the future.
Exactly. You're still the one making the choice. It's just that the outcome of that choice from an eternalist view is already part of the structure of space-time.
Okay, so it's not that my choice is being forced by the future. It's more like my choice is what shapes that particular part of the future. It's still pretty mind-blowing, but at least it feels like I have some agency.
It's a tricky concept, for sure.
It really is. But this whole idea of the future influencing the past made me think of all those mind-boggling paradoxes. You know, the classic time travel stories about changing the past and creating all sorts of ripple effects in the present.
Yeah, paradoxes are definitely a major challenge for any theory that involves time travel or backward causation. They're often used to argue that these things just aren't possible.
Right, because they create these logical contradictions.
Exactly. And we can group these paradoxes into three main types: bootstrap paradoxes, consistency paradoxes, and Newcomb's paradox.
Okay, a whole family of paradoxes. Let's take a closer look at each of them, starting with bootstrap paradoxes. What makes them so paradoxical?
Well, imagine a causal loop where event A causes event B, which then causes event C, and then C circles back and causes event A. It's like a self-creating, self-sustaining loop with no clear starting point.
Okay, that's making my head spin.
Yeah.
It's like the chicken and the egg, which came first.
Yeah.
But with time travel added in.
Exactly. And the paradox is that something seems to be coming from nothing. Event A needs event C to exist, but event C also needs event A. It's a circular dependency that just doesn't make sense with our normal understanding of cause and effect.
Right. So bootstrap paradoxes challenge the idea that every effect has to have a separate, distinct cause. They suggest that these causal loops might actually be possible.
Yeah, it's a wild thought.
What about consistency paradoxes? Those sound like they could really mess things up.
Consistency paradoxes are those classic, what if I go back in time and kill my grandfather scenarios.
Right. The classic time travel dilemma.
Exactly. And the paradox is that if you actually manage to change the past, that drastically you wouldn't exist in the present to go back in time in the first place, it creates a logical contradiction.
It's like erasing your own existence by changing the past. These paradoxes always make me wonder if time travel stories can ever have a truly happy ending.
It's tough to imagine.
So how do we even try to resolve consistency paradoxes? Do we just have to accept that they're inevitable if backward causation is real?
Well, one philosopher, David Lewis, he offered a really interesting solution. He argued that our ability to act always depends on the context.
Context.
Hmm.
Okay, how does that apply to time travel and changing the past?
So Lewis suggested that while you might have the ability to kill your younger self in one context, the very fact that you already exist in the present makes it impossible in this particular context. It's like saying you have the ability to speak a foreign language, but you can't do it right now because you've lost your voice. The ability is there, but the context prevents you from actually doing it.
Ah, so it's not that you lose the ability to change the past. It's that the context of your own existence makes it impossible to do things that would contradict that existence. It's like time itself is setting up these rules to protect the consistency of reality.
That's a great way to put it. But there's another layer we need to think about. Even if we accept Lewis's contextual solution, we still have to ask what actually prevents these paradoxical actions from happening.
Right. Can't just be a matter of logic or context. There must be some sort of physical or maybe even metaphysical principle at work.
Some physicists think that the laws of physics themselves might have safeguards in place to prevent consistency paradoxes. They point to things like quantum mechanics, which governs the behavior of particles at the subatomic level.
Quantum mechanics. Now we're really getting into the deep end of physics. How could quantum mechanics prevent us from changing the past?
It's still very speculative, but some physicists propose that there might be fundamental rules within quantum mechanics that ensure consistency even if there's backward causation going on. They suggest that even if you could interact with the past, you wouldn't be able to change it in a way that breaks the overall consistency of reality.
Okay, so it's like the universe has a built-in safety mechanism.
Kind of like a cosmic rulebook.
That's a bit reassuring in a the universe probably won't implode kind of way.
Exactly.
But even if we can avoid creating paradoxes, the implications of backward causation are still massive. It really changes how we think about time causality and even our own choices.
It challenges some of our most basic assumptions about how reality works.
So we've explored bootstrap paradoxes and consistency paradoxes. Now we have one more to tackle Newcomb's paradox. What makes this one different, and how does it relate to backward causation?
Newcomb's paradox is a really fascinating thought experiment. It throws a wrench into our understanding of decision-making and free will, especially when we add in the element of prediction.
Okay, I'm ready for another brain twister.
All right, so imagine you're playing a game against a being that has a perfect track record of predicting what people will choose. Let's call this being the predictor.
Okay, a perfect predictor. That sounds a bit intimidating.
The predictor shows you two boxes. One is transparent, and it has a small amount of money inside. The other box is opaque, and it might have a much larger sum of money, or it might be empty.
So there's an element of risk. I like it.
Here's the twist. The predictor has already made their move. Based on their perfect knowledge of how you make decisions, they've either put the larger amount of money in the opaque box or left it empty.
So they're anticipating my choice before I even make it. This is getting good.
Now you have two choices. You can either take just the opaque box or you can take both boxes.
So do I trust the predictor and go for the potentially bigger reward, or do I play it safe and take what I know is there? What's the paradox?
The paradox is that there are strong arguments for both choices. If the predictor knows you're going to be greedy and take both boxes, they won't have put the money in the opaque box. But if they know you'll trust their prediction and just take the opaque box, you'll win the big prize.
So it's a game of trust versus greed. I can already feel the tension. What are the arguments for each choice?
Well, you could say that the predictor has already made their move, so you might as well take both boxes and try to get as much money as possible.
That's the I want it all approach.
Exactly. But the other argument is that knowing the predictor has never been wrong, you should just trust them and take only the opaque box. After all, if they've always been right in the past, choosing the opaque box guarantees you the bigger payoff.
But isn't that assuming that I don't have free will? If the predictor already knows what I'm going to do, how can I possibly choose differently?
That's the core of the paradox. Newcomb's paradox really makes us question the relationship between free will and a future that seems predetermined. If the predictor is using some kind of backward causation to make their choice, it seems like our actions are already set.
Right. It's like our choices are determined by the future instead of us shaping it. This paradox is really messing with my head. But I am curious to know more about how all of this connects to physics. We've been talking about backward causation in a philosophical way, but does it actually have any basis in the real world?
That's a question that's really captured the imaginations of both physicists and philosophers, But it's important to remember that in physics, causation isn't really a fundamental concept.
Wait, really? We've been talking about it this whole time.
I know it sounds strange, right? We talk about causation all the time when we're describing how things work in the world. But physics, it tends to operate on more fundamental levels, like interactions, energy transfer, the laws of motion.
So how do we even begin to think about backward causation in physics? If there's no like causation button we can press?
It's all about trying to find physical processes that show us a cause and effect relationship, but in a way where the effect happens before the cause.
Okay.
And there are a few ways to approach this. Some physicists have connected backward causation to things like the transfer of energy, or the conservation of certain physical quantities, how forces interact, or even those weird microscopic interactions we see in quantum mechanics.
So it's like we're taking our philosophical understanding of backward causation and trying to translate it into the language of physics.
Exactly.
But doesn't physics have that fundamental law about time reversal invariance? I mean, doesn't that suggest that things should be able to happen in reverse?
You're right. You're talking about the fact that a lot of the fundamental laws of physics are time symmetric. They work the same way whether time is moving forward or backward. Imagine watching a video of a ball bouncing. Now play that video in reverse. It still looks physically possible, right?
Right.
Oh.
It's like the laws of physics don't really care which way time is flowing. So then how do we explain the arrow of time? Why do we experience time moving in one direction if the laws themselves are reversible?
That's a huge question. One that physicists are still trying to figure out. One of the leading ideas is that the arrow of time comes from how large numbers of particles behave statistically. Think about entropy, that tendency for systems to become more disordered over time. It's just way more likely for a broken glass to stay broken than for all those shards to spontaneously jump back together.
Right. It makes sense. We see time moving forward because things tend to get more chaotic, not less.
Exactly.
But how does this connect back to backward causation?
Well, if the fundamental laws of physics are time symmetric, why don't we see backward causation happening more often? One possibility is that it's just incredibly rare. The conditions you need for an effect to happen before its cause might be so specific and so unlikely that they almost never occur naturally.
So maybe backward causation is possible, but it's like winning the cosmic lottery. It's not something we'd expect to see every day.
Exactly. Now, there are some really interesting ideas in physics that might hint at the possibility of backward causation. One example is the Wheeler-Feynman absorber theory. It suggests that electromagnetic radiation might actually travel both forward and backward in time.
Whoa, so light waves could be traveling back in time from the future.
It's a pretty wild concept, and if that's true, why don't we see those backward traveling waves?
Yeah, good question.
Well, the theory says that because the universe has absorbers, they essentially cancel out the effects of those backward traveling waves. So it ends up looking like radiation only travels forward in time.
It's like the universe has this built-in mechanism for hiding the evidence of backward causation.
What are some other physics concepts that have been linked to backward causation?
Well, there's the idea of tachyons. Those are hypothetical particles that travel faster than light. Some interpretations suggest that tachyons could experience time in reverse, which could open up the possibility of backward causation. And of course, there's quantum mechanics, which is full of bizarre phenomena that challenge our classical intuitions about time and causality. Quantum mechanics is always good for a mind-bending adventure. What kind of quantum weirdness could point towards backward causation?
Some interpretations of quantum entanglement, where two particles are linked so tightly that they share the same fate, even when they're separated by huge distances, suggest that measuring one particle in the present could instantly influence the state of the other particle in the past. There are also these delayed choice experiments, where a decision made in the present seems to affect how a particle behaved in the past.
It's like the future is reaching back and tweaking the past. These quantum phenomena are really challenging how we think about how time and causality work.
They really are. It's important to note that a lot of physicists are still skeptical about backward causation. It's still a very speculative and debated topic, but it's a concept that forces us to confront the limits of our understanding and to consider possibilities that might seem really strange at first glance.
This whole deep dive has been like a journey into the realm of what-ifs. It's incredible to think that something as fundamental as the direction of time might not be as fixed as we once believed. We've explored some mind-bending concepts that really push the boundaries of what we think we know about reality.
And that's the beauty of philosophy and science, By questioning our assumptions and exploring these seemingly impossible ideas, we can discover completely new ways of understanding the universe and our place in it.
We've covered a lot of ground in this deep dive into backward causation. It's clear that this concept has huge implications for how we understand time, causality, free will, and the very nature of reality itself.
Yeah.
But as always, we want to leave you with a question to ponder.
If backward causation were real, what would that mean for our understanding of responsibility? If the future can influence the past, does it change how we view our choices and the consequences of those choices?
That's a question that could keep philosophers and physicists debating for centuries. It reminds us that the search for knowledge is never truly over. There are always new mysteries to unravel, new possibilities to explore. So keep questioning, keep exploring, and keep diving deep into those big ideas. Until next time, thanks for joining us on this wild ride through the mind-bending world of backward causation.